All right, back to here. Here we are, non-silicates. We're talking about sulfides and oxides. If you remember, sulfur and oxygen are called the chalcogens, which means ore-forming minerals. Okay, back when we did the different groups or families on the periodic table, and that's because a lot of times iron sulfide, and iron oxide, and copper sulfide, and copper oxide, and some of those other ones are very often they combine with a lot of those. Valuable ores that we would use to process to get the iron, the copper, and the zinc and various things from them. And so that's why this group is called that. With iron and oxygen, for example, you can get iron oxide. You can have hematite, which is a red mineral. Surprise, surprise, because it's kind of rusted basically. Magnetite, which is a mineral that is actually magnetic. Okay. If you mess it with tin, it is called cassiterite, but that is a source of tin. U is uraninite. All right, I misspelled that. Uraninite. Should be a T in there. Sorry. Uranite. Uranite is the mineral we get uranium from. And manganese is pyrolusite. Okay, chromium is chromite, and you get the idea. Over and over again, different metals that we like to process are very often joined to oxygen, and the same is true of sulfur. Okay, lead sulfide, for example, is pyrite or fool's gold. Okay, but it would be a good source of lead, and so forth. So a lot of the sulfides and oxides are that. Now we have halides, which we should recognize again, the hala prefix. This is the halogens. So these are a metal plus a halogen, or the salt-forming minerals. A lot of these are chlorines. Sodium chloride is rock salt, halite. A lot of times they're fluorine. Sodium fluorine is toothpaste. We put in our toothpaste to help protect our teeth and so forth. And so a lot of these, you could also have iodine and bromine, but by and far, fluorine and chlorine are the most common ones. All right, so these fluorides and chlorides, the halides, would be a metal plus a halogen. All right, we could also have sulfates, which, unlike the sulfides, are just a metal plus sulfur. This would be a metal plus SO4, which is sulfate. All right, and then the last group would be the phosphates, which would be a metal plus PO4. Okay, and so the phosphates, so all these different groups and minerals, as you can see, are named for their chemical names, and so that makes it pretty handy, and that's why we learned those. All right. I want to talk briefly about the formation of minerals. We talked about this a little bit earlier, some of this, but basically most minerals, since they are crystals, are formed by crystallization. And that can happen two different ways. One, when water evaporates, so you have evaporites, could be called evaporites, when water evaporates. Okay, so this is when water evaporates. So these are things, you have something dissolved in it, like salt water, for example. Rock salt was probably, we had a lot of inland oceans, we think, that evaporated away and left the salt behind. And so you have these salt beds, and then they've been buried by other stuff, so now you have these salt layers underneath. And those would be examples of evaporites. Okay, calcites, gypsum, some of these other ones we think were dissolved in water, and then when the water evaporated, that was left. Others were when magma, which is liquid rock inside the earth, or lava, which is outside the Earth's surface. Once it gets above the surface, it's called lava. Same difference. Melted rock. Okay, when that melted rock cools down, then it begins to form crystals. Okay, and so either way, either the actual material was liquid, which would be magma or lava, or just that it was dissolved in water and the water evaporated away. Either way, it leaves crystals. Now, if the process happens, we said slowly, then you're going to get big crystals. All right. If the process, either evaporation or cooling, happens quickly, you're going to have very small crystals. All right. And so that's just one of the main characteristics of minerals are their crystals. And when we start talking about rocks and minerals and want to know what kind of conditions they formed under, this is one of the indications that might tell us about whether they cool off quickly on the surface, or are they below Earth when they've cooled down, and things like that. All right. Now, rocks, just talking about rocks, then when you switch to rocks, these are minerals. We talk about how they form, and then they form rocks. Rocks are basically just a combo of basically two or more minerals. All right. And it's a physical mixture. It's not a chemical reaction. They don't react with it and make a new chemical. There's still two different chemicals or two different minerals in the rock. Okay. And sometimes these may be heterozygous, where it's very obvious that just by looking at them to the naked eye, as we say, that they are different. They have different minerals, and you can see the different colors or the different crystals or whatever, and you can tell them they're alike, or they may be homogeneous. Oops. There we go again. Heterogeneous. Okay, heterogeneous and homogeneous. All right. Heterogeneous, or they may be homogeneous. All right, and they may look this, so it may just all look the same, but if you look at it close, you can see that there are different crystals, or microscopically or something like that. You may have to do that to see it, but they are made of different kinds of. All right. I'm really trying to cut down the number of times I say all right, but then I guess on the other hand, if it gives people something to do, like count how many times I say all right during a lecture, it keeps them from falling asleep. That's not a totally bad thing. Next, though, we want to talk about the three types of rocks. Three major groups. And this is classified basically about how they came to be. The first type is igneous. All right, and igneous means basically fire formed, or formed in fire. All right, and usually we think fire and stuff like this, so we're thinking about lava. And so they're basically either formed from either magma, which once again is below the surface, or lava, which is above the surface that has cooled and crystallized. All right. So in identifying these and where they came from, it's very important to look at the crystals. If they're very fine, like lava rock has big bubbles in it, but you can't really see any crystals. So we know it cooled fairly quickly. Frothy type stuff, frothy lava on top, or maybe it was even thrown into the air and mixed with the air, and that's what makes all the little air bubbles and stuff in it. Okay. So a lot of the crystallization, the size of crystals, and air bubbles or not, and things like that, give us an idea of where they were formed. Okay. If they are formed above the Earth's surface, these are called extrusive. All right, extrusive, X as in exit, so they exited the surface. So these are above ground. Basically, they formed above ground. They were actually, extrusive actually means pushed out. So the lava, the magma, if you will, was pushed out of the ground and became lava. Okay, and so those would be extrusive rocks. Intrusive technically means pushed into, but basically they stayed in, they cooled while they were still underground. Okay, so above ground basically, and underground rocks. Extrusive or intrusive. Extrusive, not surprisingly, tend to cool down faster in the air, and therefore they tend to have small crystals. Intrusive very often cool very slowly under the ground, and so they very often will have large crystals that can be seen with the naked eye. All right. Extrusive rocks are basically formed when lava, then it becomes lava because it's above the Earth's surface, and it's usually pushed out of, lava is pushed out of fissures or cracks in the Earth's surface. Okay, and when it's pushed out of those, okay, fissure eruptions are more common, and they can occur underwater or on land. We think about the surface, we tend to think, oh, it's up on land, but it can also happen underwater. Very often, this just bubbles up underwater, and as soon as it hits the water, it begins to cool down, produces steam, which may bubble up to the top, but it just sends out and spreads out along the bottom. Okay, a fissure is basically just a crack where it just oozes out and spreads off to the sides. It's not very explosive. Volcanoes, on the other hand, have a vent. Okay, there's a shaft, kind of, if you will, that goes down, and it just comes shooting up that shaft. However, usually it's been hardened, and so the shaft may have a plug. All right. And so sometimes if it plugs and builds up pressure of magma trying to push on this, then when it finally blows, it may blow up really big and may take a lot of the mountain up with it and blow it up in the air like Mount St. Helens did. I won't say about 1976, but it's been so long I can't really remember now. Generally, these are going to cool very fast because they're above the surface, so they're going to have small crystals, and they may be very small or even invisible to the naked eye. You can't see them. Intrusive. On the other hand, are what we call plutonic rocks. Pluto, the god of the underworld, so plutonic or intrusive rocks are formed in the Earth's surface. All right, and once again, they're going to have usually cool slowly. They're going to have larger crystals and so forth like that. Now, if you look at this is kind of a picture of a landscape. You can see in some places where magma has come up, it may just flow out on the sides. This would be like a fissure flow where the lava has flowed. It may come up a central vent like a volcano. If it clogs up, it can be kind of very explosive and come off shooting out all different directions. Or it may just roll down the sides and make different layers every time some oozes out. In Hawaii, for example, many of them are not explosive, and they just send out new lava and just makes new layers, new layers, and new layers. Sometimes they cool down underground, but then they get worn off. If all this stuff erodes, then you may have a mountain. For example, Enchanted Rock in down by Fredericksburg is a huge granite. It's very round. Okay, it's very rounded like this, and it makes it very unique. But as all the dirt eroded around it, you were left with this big dome, and so it makes it a very unique unique formation. But originally we think it was underground, and then over time it was eroded away so that you could see these other things. So that's just kind of a quick introduction. You can see there's little sideways things called sills and laccoliths where it comes up and then it spreads out and so forth. We're not going to worry about all those names. Just kind of want you the idea of these are intrusive rocks if they're underneath. If they form up on the surface, then they are extrusive. The second type, so we have igneous with its extrusive and intrusive, all of which is cooled down lava or magma. Then we have sedimentary rocks. Sedimentary tells you that it's made out of sediments, and basically that means small pieces of things have been deposited somewhere, and they're most common in the upper layers of the crust. This can only be deposited or formed at the surface. Okay, they can't be down inside the earth. They're only formed on the surface. And basically there's four main steps. First of all, you have to have weathering. Weathering breaks off little pieces of rocks and so forth, and it's called weathering because many of that is caused by weather. Okay, it's just the disintegration and decomposition or breaking down of rocks. This is basically what makes soil. Soil is sediments, kind of the same thing. And to a geologist, sometimes they just look at soil as pieces of rock that are too small to be important, but soil is what grow plants and all the things that we depend on. So it's very important to us. There's mechanical weathering, just physically breaking it down, whether by rivers rolling over it, tree roots actually breaking through it. You've seen trees growing. Alright, put that S here. Tree roots growing through rocks and prying them and breaking them apart. Just rocks banging together. Rivers roll the rocks along the bottom and they bang into each other. All these things that can physically break it down. Now they can also have chemical weathering. Okay, And in this case, they react with water and its solutes and things like that to help break down the rocks chemically. Included in this are lichens. Lichens are little fungi and